miss anything down here? All right, so moving on to forum questions. This is HTM Forum. This is the premier, wait, what is the code for this? Yeah, I just threw a link into chat. This is the place to be if you're into HTM, hierarchical temporal memory, or just brain-inspired intelligence algorithms. But we're talking like really brain-inspired. Like, we want to understand how it works in the brain and be able to like teach people how it works. Not we're not trying to come up with a formula, or I don't know how to say it. We want to understand it. We don't just want to create solutions based on a loose interpretation of how neurons in the brain work. We want to really understand the core of intelligence. So if you're interested in that, here's the place to go. I saw this on Twitter. This is interesting. So BitKing's one of our most active and popular members on the forum, and he's online right now. I know. So this pattern induces predictable and repeatable activity deep in the brain. Yes, they know what you're seeing when you look at this. And by deep in the brain, I assume, wait, yeah, what do you mean by deep in the brain? Deep in the cortex, like layer 6, or are we talking about like deep like thalamus? I'm just curious. Deep image synthesis. To what extent are predictive deep learning models of neural responses useful for generating experimental hypotheses? Okay. And they analyze the effectiveness of these images in producing the desired effect in a macaque visual cortex. So it's all visuals. Oh, okay, so hierarchy. As deep as, but, well, the question is, are they, I would assume they would induce predictable and repeatable activity everywhere in the cortex. V1, the visual cortex, excuse me, in the visual cortex. V1, V2, V3, V4. At least that's what the 1,000 brains theory, I think, would suggest. Is that what they found? Conducted several closed-loop neurophysiology experiments. Model-generated synthetic neurocytes beyond their... Current embedded knowledge already has potential. Oh, that reminds me. There's a paper I'm going to add to this list. There's a paper that I wanted to review. That's the I sent out. I'm just removing this Dementa research meeting because I'm going to do it. Yes, and very, very repeatable. These target deeper maps. That's interesting, and that doesn't surprise me at all. Cool. This is really interesting, and it doesn't surprise me at all. To take it a step, let's say the 1,000 brains theory would say, would posit, would predict this, what did they call it? Repeatable and what was it? They used a certain phrase. It was like repeatable and maybe it was here. No, you used it. Predictable and repeatable activity. That was your words. That's exactly, those are the right words. This repeatable and predictable activity would also be seen in V1. Whoops. No. What the heck? V1, V2, V3. That makes sense. That's cool, Mark. I like that. I love stuff. This is neat. there's a little bit of a feedback loop right now between all the stuff we have learned from machine learning, because that is, I mean, you have to remember that all originated from neuroscience. The point neuron models that we have all totally originated in neuroscience. Like I'm always complaining, like, this is too simple. It's too simple. We've hit a brick wall. We're not going to go any further if we're going to make AGI, which I think is true. But I don't ever discourage anyone from working in AI and current machine learning systems, because there's so much stuff you could do. There's so much stuff you can do even now. I mean, there's still frontiers to be breached in that area, I think. So go for it. And the way that AI now, like weak AI is currently informing our neuroscience communities. Like all the neuroscientists that I talk to understand machine learning, and a lot of them use it directly because they know it's such a powerful tool to extract sort of meaning from data, big data, and there's so much big data in neuroscience. Okay, back to the forums. Synapse competition. This is from DMAC. I think I don't know his or her name. I don't know anything, so I just call them DMAC. But they're very, very active in the New Big Forks. So this must be him, David McDougall. Oh yeah, I remember that now. You've said that before. Hi Nick Nil. Just pop in anytime you want. What were those V-force stimuli you showed for a second there? I'll send you the link to it. It was. I just replied to it, right? So these were these are just images. Yeah, there's a paper. There's a whole paper here in this. So I'll let you look into it. No problem. Here's the paper. Anyhow, where was I? Synapse competition. Oh, interesting. Okay, this is a big topic here. Hebbian learning threshold. Synapsism use Hebbian learning. Constant activation threshold. Discrimination between cells. Threshold is too high, then cells never activate. Inactive cells do not learn, so they never form additional synapses. Too low cells that learn from others. Yeah. Okay. I'm just trying to get a sense of this. It's hard to get a sense of a big post like this without just reading it, so. I think, so he's just talking about the benefits of competition when it comes to Hebbian learning. So as an example, in HTM, there's a mini column competition during spatial pooling. We call it a competition amongst neighborhoods of mini columns to decide which mini column will represent the current input. So that's how we sort of talk about that. So he's saying there's a component of HTM models using Hebbian learning with only a constant threshold. Interneurons as process modulators. Yeah, so that's certainly interesting. So, so my whole take on we apply what do we call it? Boosting. You know, so that's sort of our answer to the problems that arise with Hebbian learning. The competition, even with the mini column competition, you can have the same two problems here, and it's not just about the threshold. It's that there's cells that just never fire. They end up not being selected for anything in the input, and then there's cells that represent too much, and so that keeps the cells from, those cells are like completely taken advantage of. The ones that are fully active, like they're fully being utilized, but none of the others are. So we want to try and spread that utilization across the whole population of cells. So that's what boosting does. Even while we're having these local competitions, we still apply boosting. So that's which is we basically look at the active duty cycles of all the mini columns, like how much have they been active over time, and we squelch down the ones and reinforce that new meaning is sort of assigned to columns that are not being very active. And there's evidence that this is happening in the brain too. Yeah, they move the activity to keep the learning threshold at the optimal level. That's the perfect way to put it. So there's different ways that you might try and do this that might work better. The thing, there's a lot of things. I mean, this whole world that we're in, that HTM's a part of, the brain, biologically inspired, cortically inspired world. There's a whole lot of different doors that are open right now. Research doors, like I could do this way. You could fund a whole study on something like this, So this is very cool. Obviously, David's put a lot of time into this. Number of connected synapses per segment. So, number of connected synapses on the bottom here. So we've got sort of a nice. So this is sort of interesting. These big numbers here. That's the problem. I think he's trying to state that some of them have. There's two lines here. Right? Oh, and here's again the problem defined in another graph. And here's another one. So you probably don't want a curve that looks like this. So I should pull over the constraint that the number of connected synapses per segment is between 30 and 35. Permanence of synapse. So these either went to 0 or 1 for the most part. Effective synapse competition. That's not necessarily what you want, is it? Small bump coincides with the connected threshold. This bump exists on both sides of the threshold. Oh, he's saying all synapses to the right are connected, all to the left. That's the threshold. But typically, I mean, maybe you're just showing. It shouldn't look like this, right? It seems odd that most of them are 0 or 1. I don't. Activation frequencies. I would think you'd want. Well, I guess after they've learned, perhaps that's the case. And these are the remaining. These are the sort of on the fringes neurons. Or synapses, excuse me. They're still in a state of decay or growth. But I don't quite get this. Maybe I'll note that. In figure 5, what? Let me. Figure 5. Why are there so many 0 and 1 permanences? Seems odd. Okay, I'll leave it at that for now. Just like going blind results in your visual cortex being encroached upon by other areas of the brain, more so the younger the brain, the blindness occurs when there's more plasticity. Yeah. How can we use AI to make RPG NPCs more interesting? So here's what you could do. I'm talking about current AI. You could take, you could use some of the NLP tools that they have today to learn like first you have to find a bunch of data. So you need to find a bunch of words or text or something that a character might have said or used or something like that. Or you need to create a lot of that data. I'm not sure if this is going to work. And then basically you train your model on all of that text and give whatever the user is saying as some type of cue. I don't know. But there's certainly things you can do in the world of like text generation, because there's a lot of big development going on there. So you could make them feel more realistic by making their chat sort of AI powered, perhaps. But they're not going to be really smart. I mean, they're not really going to understand anything. It's just going to be probabilities. There's a good probability this is a rewarding thing to say. You know, it depends on how you train your NPC. But so as far as like HTM wise, I think perhaps the better thing to focus on for if you want to try and use HTM like brain-based stuff is location and space and movement. So we do have a pretty good idea of different ways to map space and keep memory of where you have been in space and the paths you have taken through that space. So you could potentially train an AI to navigate more efficiently with an HTM through a space. And once you've done that, you can basically give that map to any NPC, of course. But honestly, that's not a hard problem anyway, so I don't know if it's going to give you a lot of benefit, because it's like brute force navigation is pretty easy, and they've already solved even a lot of the mazy stuff with math, just math. You know, it's like all you need is a few equations, and a lot of these things just work. Anyhow, back to the Forum. Yeah, I want to get through this so that I want to read this, I want to look at this paper and get some, what happens with Bammy? So there's a Chinese translation of Bammy. This guy told me he was going to do this. So I have not verified this, and we don't have anyone right now that can verify this. But it's here, so I'm happy about this. I'm going to give you a badge, an awesome badge for posting that. Hello, is it, so now I have to figure out your username. Is it T-Heart of DHT, or is it Thart of DHT? Probably not Thart. It's not a good word. Hey, how are you doing? You here because you're interested in brains or algorithms or math, or, well, you're gonna be let down if you're here to learn about math, because I'm not a mathematician. Reinforcement learning and HTM algorithms. First post. This person is a master's student in research and deep learning, mostly in RL. Trust for reporting action. Okay, so this is cool, but I don't know enough about reinforcement learning to suggest something, honestly, because reinforcement learning. Let's learning. I want to look at a diagram. I have to see a diagram of anything. An introduction to concepts application. I want to see where is the deep learning network in this system. Well, and I think they're in like encoders and decoders, right? So there's some type of, or no, that was for transformers. All right, let me start from the. So somehow you take state and you have like this decision-making module, and you have to incorporate reward and feedback into that. So that sounds good because that's the way that that's something maybe you can hook HTM to as being part of the model that decisions are made upon. But I know that reinforcement learning currently, I thought there was some deep networks involved in it. Observation, reward, process diagram. Uh-oh. It's spam again. Every day. Every day. Markov state reinforcement learning agent. So there's this policy function. The agent's behavior function is a map from state to action. So I think we need a stochastic property, right? I always don't look at me negatively for looking this up. Stochastic is randomly determined. Okay. All right. So random probability distribution. Deterministic is not random. So it can be either one. Hello, E-Wade. I'm trying to understand. I've never really investigated reinforcement learning, and I'm trying to understand what part of it is is there a Bayesian model in here? Where's the deep learning part, network, what? So there's a policy, a value function, and a model. So HTM would be the model in this. This is the best we have to offer the DL camp at this time. What is? So what I can do is I can point to this and I can say HTM would be the model, but the thing is the whole reinforcement learning setup is still sort of established as a spatial search, a spatial problem, right? And from what it seems like, if you're trying to create all of the reinforcement learning, like AI, OpenAI Gym or whatever, they're set up to solve this in a spatial way. But you need a model that can change at every time step. That's the thing. You need a model that can change, and I don't know if reinforcement learning systems will allow that. So I think that's what I'm going to say. I think HTM could be an excellent model, a capital M model, to use for RL systems. But I see a big problem. We can provide the anomaly score as a training signal for the RL inputs. Yeah, so that would encourage like familiarity, like finding things that are familiar, or maybe even perhaps learning something that, or leaning towards observing something that you already know a little. There's a lot of things you could do. So the problem is that all the RL systems today are still set up as spatial processing problems. And HTM model needs to change at every time step. It must be an online learning model. If you can find an RL framework that allows models to be updated at every time step, I would start there. And I will also say what you said, Mark, in chat here. That's sort of like I guess I could say that. You could use the model's anomaly scores to help let's just say as part of the training signal. something like that. Okay, I'm gonna mark that. I'll post the video of me blathering on about this. Okay, biconditional generative networks. Imprint the memory and collective experience of an agent. Here's what's biconditional generative networks. This is not HTM related, I don't think. This looks like deep learning. Thank you. This is a Spotify playlist called Nighttime Lo-Fi, and it's one of my favorites. And it's 14, almost 15 hours long, so you're not gonna run out of tunes. And it's all chill tunes. Okay, I'm gonna skip this because I don't think this is, I think this is, no, maybe look at it and just confirm the type of network we're, oh yeah, I know you. You've posted some of your papers before to the forum. Example for raw 0-1 input data. Okay, just a new post, new forum member. I wonder if there is any simple anomaly detection example with some data source other than CSV files. So you've got images. You went 8, and I make a 1D numpy array. Okay, difficulties with running example of input data. I couldn't find an example of such. Obviously, such data doesn't need any encoder or decoder. Besides that, could HTM Nupik handle such a long array of data? Okay, so it's probably not going to work the way you're trying to do it. So let's step back. Let's step back here. Okay, let's start at the beginning to better understand what you are trying to do. Let's put this up here. What are the images of? Are they sequential? All right. Yeah, let's just start with that. That's a good question. Okay, trying to make, okay, so we already had a new member introduce themselves, which was nice. They're seeing someone reverse engineering the brain got the attention. Just getting sick of machine learning, exploring other ways. Great. Those are the people we want. We want people that are looking for other ways. You know what? I'm gonna say that inspired a lot of people like me. That is great. We are looking for the people. I'll leave it at that. Okay, trying to make an HTM augmented-based reinforcement learning system. This is a resurrected post. Dreams control lucid dreaming and neuroscience. Oh my. Lucid dreaming. So if you know what lucid dreaming is, when you can control your dreams. All right. The mechanism behind lucid dreaming. Before you can think about the mechanism behind lucid dreaming, you have to sort of explain the mechanism behind dreaming. I don't know that science. I don't think science has answered that. I have some ideas, but they're just ideas. Okay, I'll probably back out of this topic. All right, I think that's it. Mark, did I miss anything? You always remind me if I missed something. forum Q&A. Still have an hour. I'll be right back. I'm gonna use the restroom. Review footage from Jet. What happened? Oh, you did have some things. All right. Oh, these are your opinions of what happens in dreaming. Okay, I'd love to read them, but I don't have time to. For anyone else who's interested, there they are. I am going back to my whiteboard. Does anybody online, anybody in chat right now know anything about transformers? And about this, you know, all this NLP stuff that Google's been doing? Not Google, OpenAI. So I saw some, this was one of the things I was going to look into today. Because this looked really interesting. So let me show you. The illustrated transformer. And before that, there was this other one. Visualizing a neural machine translation model. This is seek to seek with attention. I wanted to understand how a transformer worked, and this said in the previous post, we looked at attention. And attention is like a mechanism, a neural training mechanism. I was trying to understand this over the weekend. Yeah, so I was wondering if anybody had any experience with these the idea of transformers and attention. I should put this in the right. And I don't know why, I just was curious because I see them in the text that I'm reading sometimes, and I want to figure out how they work. Because these terms, like especially encoders and decoders, you know, they're related to, they're terms that we use in HTM, but they mean sort of different things. And I want to know when I'm talking to somebody about this, how my terms are overlapping with the current terms. Hi, James. Just stack more layers. Are you the same guy that came last week and kept telling me to stack more layers, bro? I thought you had a different name then. Yeah, just stack. All of the best performing models are like really, really deep. Okay. I don't know that I'm going to do this right now. I'm interested in this, and if anybody wanted to talk about that or had any insight about the attention mechanism, seek-to-seek models with attention, I'd be willing to open up like voice chat and chat about it. turned in your thesis today. What was your thesis about? Machine learning? You just stack more layers? Is that your thesis title? Stack more layers, bro. Progressive web apps. Oh, well, I used to work in web apps a lot. Okay. All right, let me find this video. I want to take a look at this video. I'm not gonna be looking over the entire thing. Now I have to remember where it is. I think it's on a disk, or maybe it's on my desktop. I'm not very good at arranging things, apparently. This is my desktop. Screenshots, icons. Look at that. Oh, I should probably clean up my events too. So I've only got like half an hour, 45 minutes. Maybe I don't need to clean up my events. I don't have many events coming up. Today, oh yeah, we're talking about, that was another thing I should have written up here. We're going to have an AI chat later, AI neuroscience chat. We're talking about semantic fingerprints, Cortical IO. So yeah, I do need to put some events up here. Let me write that down. All right. Let's make a neural network in Angular. Oh, that sounds awful. I mean, I don't want to do that. Okay, I think I'm pretty sure that the videos on this drive here. I hope. Man. This was a good interview. And I got pretty decent video of it too. So I'm gonna put it on YouTube, and also I'm gonna put it on finish my build HTM. I'm gonna do that at least one day a week. I might try and do it two days a week. But I'm trying to do two things. I'm trying to do the build HTM systems thing. Well, I'm trying to do a lot of things. But for Twitch anyway, build HTM systems at least one day a week. And then I need to have like a Python 3. I want to get HTM and Python 3 working properly, well. And I want to help the community get to a point where people can pip install some HTM. I want to get them so that the community fork can be pip installable from Python 3. And once we get that, I'll probably stop doing that, because we need an HTM available in Python 3. So I'm going to keep working on that on Fridays or Thursdays or Fridays. And this morning, today I'm not working on any of that stuff. I'm just basically getting ready for a research meeting at 10, and I'm trying to like wrap up doing a bunch of little things until that happens. And the research meeting will probably go on for a couple hours. Oh, one of the things I wanted to prep for the research meeting was this paper review, because Subutai brought it up and it might be something we talk about. So let me do this real quick. Let me find this. Lacey. I don't mind if you guys see this. I've got this giant, all of my media projects are on this external hard drive. Oh good, here it is. Okay. So I've got one 4 gigabyte movie of me and him, and I've got hopefully better quality audio. So what I'm gonna do is show us my anime folder. Did I have an anime folder? I don't think I have an anime folder. There's an archive. It's not anime. So what I want to do here, is what I usually do is I'll create, why is it doing that? An audition. Ugh. What just happened? So I'm going to create a Premiere project here because I'm going to turn this into a video and a podcast. This was a good conversation. So I don't know what you guys are talking about. So let me go back to my Lacey here. First of all, I need to make sure that Premiere is updated. Apps. Premiere Pro. Okay, it is. And I've got this one project that's a template for everything, and I want to make sure it's up to date. So I use this Premiere. This is Adobe Premiere. It's for video editing. And I found when Deadpool came out, the editor for Deadpool, the movie, uses Adobe Premiere, and he made the template he used for the whole project, like his project template for Premiere, available on the internet. So I downloaded that and sort of customized it a bit, and it's worked out pretty well. It's if it'll ever open, it is not opening. It's taking forever to open. So what I'm gonna do is, as soon as this opens, for Christ's sake, it's like loading every bundle known to man. I will just basically set up a shell, put the videos in it, and make sure that they play and they track well, and that I can get the audio synced over the video, the best audio synced over the video, so that I'm in a place where I can produce it. That's just something I can do in 10 minutes. Because once I sit down, then I'll be ready and I can sit down at Premiere and spend, an hour doing an editing session. Because that's something like programming. Editing is sort of similar. You want to get your headphones on, you want to get in the zone, it's hard. There's a lot of different, like if you want to do something right, it's a long process of steps before you get the edits in the right place. So I feel like editing is sort of a similar mental process for me as programming, especially animating, when you're moving things around a lot and pulling things in and out. This is ridiculous. It's still loading. Oh, here we go. That took forever. Okay, this project was saved from a previous version. This is what we're looking at here. And it wants me to save it as, that's fine, whatever. Okay, so that's why I did that, because I want that version. So I'm going to put this down, remove this old one. And so this just updated the template. Every time, there's a breaking change every time you update your project, and you have to save it as a different version of your project. So that's sort of frustrating, but so anyway, I'm gonna take this project template, I'm gonna copy it and put it right here. Paste, yeah. And I'm just gonna call it Premiere. And this is gonna be, call this Jeff on defining intelligence. Open that up, and it's opening in the wrong display. So stand by. But it's not downloading every bundle because it's already downloaded the bundles. Editing is exhausting. Editing can be very exhausting. Okay, so raw footage. That's where I want to put stuff. So I've got footage over here, sort of in this root folder. So I'm gonna move it into footage, and it's wide camera. Okay, and this is gonna be in sound. Production sound. All right. Little anal, I know, but this is important once you start getting a complicated project, and it's hard for me to tell what's going to get complicated. So then you have to drag it over here like this and drag it into Premiere. So now I've got this. You guys hear that? It sounds really... That is very quiet, but that's quieter than I really ever want to hear. Why is it so quiet?
If you do it that way, you can always engineer a solution to do X better.
Yeah.
So we end up
That's
with
what
both.
we have today.
Yeah,
That's
we
what
do.
we have.
We have these.
I don't understand this. This pisses me off. I've been using this recorder for ages. The gain should have been higher. I don't understand why the gain wasn't higher. Anyway, I'm not going to deal with it now. I just want to get the things in the right places. So the other place was footage, camera, wide. We're going to move that into sequences. No, raw footage. All right, so now we're going to create a sequence called, well, there's already a sequence called selects, and we'll use that. So we're going to drag the main movie over there, keep the settings of the movie, and we'll have to change the settings of that. And we're going to drag the audio also into here, and we're going to sync it. Okay. Assembly. And I haven't done this in a little while, so bear with me. It has been a little bit. I know. Oh, how did I get that? Okay, here's what I gotta do. View, window. I screwed up. There's like a reset. I need to reset my window. Workspace is reset to saved layout. Okay, yeah, that's better. That's what I want. All right, so why can't I get to editing? That's what I need, editing. Okay. So I want to scale this up. So that's basically it. I'll just scale it to about right there. Okay, so I will sync this later. I'm just going to save it. I'll sync it later. So I'm ready to edit, basically. That's what I wanted to be in. I wanted to get in a position where I was ready to edit. And I'm ready to edit. There you go, everybody. Ready to edit. I will... Not sure if I'm going to do that live or not. I guess I could. Lucid dreaming. Okay. The paper. Let's look at that. Let's look at that. I'm going to open my email in my other window. This paper, I've got a PDF of it, but looks like it's open access. So let me find the link so you guys can all see it too. It looks pretty interesting. In vivo, functional mapping. There we go. 6 days ago, in vivo function. I don't know if this is the original site because this is open access. This should not be. You could probably get on ResearchGate then. You should not have to pay for this. You should be able to get this open access. All right. I try not to have too much of a life outside Twitch, but you know. All right, the PDF. So, all right, so I only looked over a part of this, but this looks super interesting because it is in vivo, so we're not talking about a fully anesthetized animal. Have you seen this, Mark? You will like this, I think. This is, I don't recognize any of these names, but I am not a neuroscientist, so, but somehow they've done some, through calcium imaging, have been able to reach down and record all the way down through layer 6. You read it yesterday? Yeah, so I'm open to, I haven't read the whole thing yet, but I took a perusal yesterday and I was like, this is interesting. So they're talking about cortical columns, and we're always looking for things that are in the area that we are studying, and we're studying cortical columns and mini columns, and so anything that comes out of the experimental neuroscience community is immediately relevant there, just to, if it can validate. Did you comment on the forum? Was this on the forum already, Mark? It's possible I missed it, because if it wasn't, I was going to post something about it. It might be. No, in vivo functional mapping. Intercortical column voting mechanism. No, this is different. Anyhow, anyway, let's look at it. So I read through this. So let's go to the graphics, because there's, I don't completely understand calcium imaging, but I know it's a way that you can get, I think, voltage, and I think that's what we're showing here is actual voltage spikes of an individual cell, 3 individual cells in one layer, this being L5, and the same thing over here. So we're, and more than just 3, I think there's available here is more than just 3. I think this is just showing an example. So this is cool because we usually don't get to see the activity in layer 6, layer 5. You know, down the lower you get, the harder it is to get this type of data. Just threw my croissant in the trash. Right, so. So Mark says how they did it is a big part of the paper. Yeah, and all the layers need to be involved in the response. That's consistent with my reading of it too. And I glazed over at some point in here because I'm not so interested in the mechanism of how they do it, but I am interested in the tonograph map, you know, and wondering. This is super interesting. Like this part here, 32 kilohertz versus 4 hertz stimulation. You know, activity moves from one part of A1 to another part of A1. So that's interesting, right? That not sure what to say about it, but I would expect those tones to be represented differently. Thanks, Mark Brown. You're a gentleman and a scholar. So, I don't know if they're going to bring this up in the research meeting or not, but at least, I read too many papers. But at least you have a chance to look at, Mark's already seen it, but the tonotopy. I'm interested in the tonotopy here. And I haven't fully decoded this chart yet. So So there's interesting, so you think about silent neurons too, because they did talk about the silent neurons, which is great because most of the reports, they just don't talk about the silent neurons. But the silent neurons are important. When you're recording some, especially if you're recording a population of neurons, sometimes there's neurons that don't do anything. They just don't fire. And during your experiment, they don't fire. Okay, so report on those, put that in your paper. How many of them that you recorded didn't fire? Because that's important context. It's interesting to know that those neurons were not involved in that particular processing, whatever it was processing at that time. They're involved in something else, probably lots of other things, but it's good to report on those. And the irregular ones are the ones that are firing, but they don't seem to be associated with the tonality, right? So the new thing that they found, Mark says, is that this wasn't just happening on the surface, it was happening throughout all the layers. No surprise here. That's good. So it reinforces, I think, our understanding of the cortical column. So that's very good. Not sure if they'll be in the research meeting, but if they want to talk about it, I'll bring it up. And I can say that we even chatted about it this morning. All right, so I've got a stand-up in half an hour, stand-up meeting. I did that. I did this paper review. Wasn't much of a paper review, but let me set up my Twitch calendar, I guess. So if you didn't know it, I keep my events on an events page in Twitch. And if you didn't know it, this is HTM Chat. It's a casual work session. Ask me anything. I've already answered the forum questions, and now I'm just working on stuff that I would be working on if you guys all were not watching. And I'm not charging my brain. Okay. So I'm trying to work out a schedule, honestly. I don't think I need this anymore. I go through a lot of whiteboards. So this is Monday. This works out well. So I'm sort of getting into habit to just coming in the office, turning on the Twitch, the live stream, and just having a casual forum Q&A and chat with people. So, and I'm calling that HTM Chat. And that's usually, I get a decent amount of viewers. There's 7 people online. That's not bad. Yeah, I noticed that slightly anesthetized. What exactly does that mean? But I can see how they might think if they're using tone, so perhaps slightly anesthetized is okay. But I don't know. I mean, that certainly is going to affect your attention. Yeah. And then we have a research meeting. And then later, I've been doing this AI neuroscience chat. But I'm thinking about moving that to another day. Because it's always low viewership. It's always low viewers. Live viewers, anyway. It's always bad. This one's generally pretty good. This one, after I break for lunch and come back at 1, because this is a 1 p.m., hardly anybody is watching at that point. So I'm thinking about moving it, maybe even moving the one today. We're going to talk about semantic fingerprints. It seems like the morning shows are better, so maybe I'll just move this to Tuesday. Maybe I'll move that to Tuesday. Let's do that. Let's do it. I don't think it really matters, right? I think at some point consistency will matter. So we'll do another HTM chat on Tuesday and see how that goes, and then move this. Do an AI neuro chat, and this will be like 10 a.m. Yeah, 10 a.m. Or it could be 9 actually. Maybe I should do it at 9. Maybe I should not do this and just do this at 9. I don't know. So we are going to have a research meeting in about half an hour. So you'll be back for, hopefully you guys will be back for that. I know I'm a little bit boring right now. I don't need this if I'm not playing any music, right? Okay, I'm going to be connecting to the office for a moment because I am going to have a stand-up meeting in about 20 minutes. So you guys won't be able to see this, but whoops. But I need to connect to the double. Because that's what I'm going to use for the research meeting. In morning, Jeff.
Morning.
I muted myself so he can't hear me now. He's always sitting right there every time I log in. Okay. Oh man, I forgot to say on Discord. Popped in. Okay. Okay, Slack. I've got so many applications open right now. I need to kill some. I still have Visual Code open. Got QuickTime. Got Spotify. Got everything. You might even consider me lightly anesthetized sometimes. I got a fresh croissant. You know what I'm gonna do? This may seem ridiculous, but I want to get somebody popped in my chat the other day and just called me a nerd and then left. Revenge of the Nerds GIF. I want to put this GIF. I want this GIF. I want it to pop up, so I need to save it. Can I just save image as, or will it? I've got a Twitch folder somewhere, I thought. There it is. I'm gonna call this Nerds. Does it work? Is it a real thing? Yeah. Okay, so I got a GIF. Nerds. All right, so that's great. And now, I think I can configure, so I have to do like a combination of things to make this work. I have to, this is sort of ridiculous, but I have to like add it to every screen on OBS. Or else it won't work right. And I'll show you there's my OBS screen. Wow. Wow. Okay. So if I wanted to show up here, for example, I need to add an image. And it pops up here, nerds. Okay. Okay. And then I have to browse for the image. It's, why is it Twitch nerds? Yeah. All right, so there it is. Okay. Unload image when not showing. I don't know what that means, so I'll just leave it. So here's the nerds. Where do I want it to pop up? I don't know. And then I will lock it in place and turn it off. How did I do this? How did I do this? Yeah, just turn it off. So I think now if I go to my Stream Deck configuration, put it right by my face. I have this section called Bang. And I think I can do something like, how did I do this one? What is this? This is a source. So I need a source. Source. Okay, Twitch 3 in the scene screen nerds. So let's see if that works. Yeah, so I can turn it on and off right there. Okay, so now what I need to do is give that thing an icon. Let me find the nerds. There it is. That's good enough. Let's get a good one. That's a good one. Okay, so. Jeez. Okay, so let's just take his whole face. Let's just take a face. Let's just try and get a square for the face. That's our pick. I don't know where that went. That went in onto my desktop, so I want to move that into Twitch. Quit. Downloads. Desktop. Screenshot. Nerds. Just move it in there. So now I can go into my Stream Deck configuration. You guys want? You guys follow me here? And I can set from file this. That's so awesome. Okay, excellent. So I think that's all it took. Nerds. I don't know why I did that, but you have to do something to amuse yourself. Nerds. Okay. I did it. It worked. Mission accomplished. I don't know. All right. So now we will move around our events a bit. And I'm still sort of trying to decide whether I want to move this. Why don't I just keep it today and just plan out next week? So I'll keep this one where it is today and plan out next week to change it. Next week, why don't we talk about hot field networks or Boltzmann machines for our AI chat? How about that, Mark? You gonna be around for? But we'll do it on Tuesday at like, I don't know, 9 or 10 Pacific, which maybe is not a good time. I don't know. Okay, so gotta go to events. You're at lunch then? Okay, we should do it. So I'm gonna leave these here. So I'm gonna add an event and okay, so now I have to hot field network. Let's find a picture of a hot field network. or a Boltzmann machine. Are they similar enough to discuss together? You know what I want to, let's look at the neural network zoo. Maybe we'll just use those pictures. There it is, Hopfield network, Boltzmann machine, Markov chain. I understand a Markov chain. What did I just do? Why is it, this isn't exactly where I thought I was gonna go. This is where I want to go. All right, so I'm just gonna swipe these because I like these pictures. We'll talk about that. And 676. That's fine. Desktop, this will probably work. Oh, is it not the right size? So I do have to resize it. Okay, size 380, no, 676. Oh, and it has to be a JPEG. For why? Export JPEG, hop, whatever. Yep, there it is. Same class. Both are fully connected. Both settle on a global state. They do it via slightly different rules. All right, so we'll try and figure that out. Hopfield networks and Boltzmann machines. All right, I'm gonna make this Tuesday the 14th. Tuesday the 14th, and we're gonna start. I'm debating on whether to do it 9 a.m. Yeah, well, why not? Let's do it 9 a.m. 9 a.m. to 10. Let's just do it for an hour. I don't know if I can talk about it for more than an hour because I'm going to be learning about it myself. All right. Okay. Okay, back to events. Building HTM systems. The last thing we did was scaffold. Okay, so now we're just going to be adding diagrams. So this, I am debating whether to do building HTM systems on Friday or Thursday because Friday I get more views. It seems like Friday is more popular. 10 minutes till my stand-up meeting. Okay. Snooze. Snooze and lose. I'm going to continue this after my stand-up, I think. Right now, I am going to... Wait a second. I want to try this again. Okay. Just going to leave it up. Like, leave it up on that screen. Okay. While you guys are staring at me, I'm just going to make sure that all of my engineering tasks are updated because, believe it or not, I am still an engineer. I still do some engineering things at Numenta. Let's see. Yeah, I got that.